Okay, this video is on the law of exponents. So here we have two terms, 3 squared times 3 cubed. Well, the law of exponents state immediately all of these laws only apply if the bases, so if this is the base and this is the exponent, you can only multiply powers of the same base. So if we would have had 4 squared times x squared, these bases aren't the same, then these laws don't apply. Whoops, the laws don't apply. So we're going to go ahead. The product rule says that when you multiply powers of the same base, so x squared times x cubed, well, that's x squared is x times x cubed is x times x times x. What do you end up with? 1, 2, 3, 4, 5 x's, or x to the 5th. So how did we come up with that without having to count it out each time? Well, if you add those exponents, you end up with x to the 5th. So the product rule is when you're multiplying powers of the same base, add the exponents. So 3 squared times 3 cubed, they're the same base. So 2 plus 3 equals 3 to the 5th. Now, because 3 to the 5th is a number, we could actually simplify that. You could do that with your calculator. Or 3 times 3, that's 2 of them. Well, that's 9 times 3. That's 27 times 3 is 81. So we have 1, 2, 3, 4. So 81 times 3 is 243. All right, the quotient rule. When you divide powers of the same base, up here when you multiply powers, you add. When you divide powers, you subtract. And it is really important to write it just like this, that when you see two things being divided and they have the same base with exponents, write the base in the numerator, take the numerator exponent, and subtract the denominator exponent. Okay, and then we have the power rule. And the power rule states that when you raise a power, so here's our power, and it's being raised to a power, you multiply. But let's see how that would work. So x squared to the 4th is x squared times x squared times x squared times x squared, right? To the 4th. 1, 2, 3, 4. Well, now we have multiplication. And what did we learn at the product rule? When you multiply powers of the same base, you add the exponents. So 2 plus 2 is 4, plus 2 is 6, plus 2 is 8. So x to the 8th. Or, so when you raise a power to a power, you multiply the exponents. So when you multiply powers, you add the exponents. When you divide powers of the same base, you subtract. When you raise a power to a power, you multiply. Then there's the zero rule that you need to be aware of. If you have any non-zero number, so you can't, 0 to the 0 doesn't work, but any other non-zero number, any non-zero number to the 0 power is 1. Let me show you why. If you have x to the 5th divide x to the 5th, you'd rewrite that as x 5 subtract 5, which is x to the 0. Well, if you come right here and just say, and remember, we have to assume that x can't equal 0 because it doesn't work if x is 0. But look at any number divide itself is equal to 1. X to the 0 is always equal to 1. So if you had a lot of things in here, x to the 4th, y to the negative 6, z to the 14th, but on the outside, that was to the 0 power, that would be 1. And then the next thing that we need to address is when you have negative exponents, what does that mean? So if we have x to the negative 1, let me see what I put down here. You're going to rewrite it, this negative sign, in an exponent other than when you're doing inverses. When you have f to the raised negative 1 of x, we'll go over that later. But when you just have a number or variable with a raised negative 1, they're telling you to do the reciprocal of that. So we're going to rewrite that as 1 over x to the first. So if we had 5 to the negative cubed, that would become 1 over 5 cubed. Well, 5 cubed is 125. So that would become this. All right, that's it for the basics of law of exponents, and then we're going to talk about scientific notation next.